Today's lesson is on chord properties for circle geometry. And the chord property is if a chord is perpendicularly bisected. So this is the chord from here to here. And if it gets perpendicularly bisected, right, this is the bisector here. It's creating this 90-degree angle. So 90 degrees here. So therefore, the bisector is running through the center of the circle. So in this case, it is labeled M. So if this chord gets bisected, perpendicularly bisected, there's 90-degree angles formed, and this bisector is going through that center of the circle labeled M. The other thing to note here is that these two lines now will be congruent. So from A to here is equal to from here to B. All right, so basically AB has been cut right in half. So if you have two chords, so in this case we have a chord here and we have a second chord here. And if those two chords are perpendicularly bisected, each one is bisected. So we can see bisected here and bisected here. The bisectors will intersect each other at the center of the circle. So these two bisectors, they intersected the circle at the center. Again, the center is labeled M. All right, so again, note here, they do make those 90-degree angles. And then when the chord gets bisected, they're cut right in half. So this half and this half are congruent. This half and this half are congruent. All right, so here, just again, a line segment that joins 2 points on a circle, that's the chord. Okay, the chord is different from the diameter. The diameter of a circle, it's still a chord, but it's going through the center of a circle. So this is the diameter, this is the chord, and like we just saw, the chord, its perpendicular bisector and the center of the circle are related. A perpendicular bisector, it intersects a line always at 90 degrees. If it's a perpendicular bisector, it will always intersect a line at 90 degrees, and it'll divide that line segment into two equal parts, just like we saw in the previous slide. All right, so this is just going over the chord properties that we just talked about. So that the perpendicular from the center of a circle to a chord will bisect the chord, meaning the perpendicular line will divide the chord into two equal parts. All right, so this was the chord here. This is the perpendicular bisector from the center to the chord, and the chord has been now split into two equal parts. And we have that 90-degree angle formed there. The perpendicular bisector of a chord in a circle passes through the center of the circle, which we've already talked about. It's going through the center of the circle. And a line that joins the center of a circle and the midpoint of a chord is perpendicular to the chord. So again, it's just stated in different ways, but here we see that 90-degree angle formed there. And it is going through the center. And that chord has been now split into two equal parts. All right, so many line segments can be drawn from the center. So in this case, the center is O. Here's our chord. The chord is A, B. So you can draw many line segments from the center to the chord, but it's the distance from O to the chord AB that is the shortest distance. So the distance, when we look at drawing a line, it has to be the shortest distance, making this 90-degree angle. So anytime we're looking at the perpendicular bisector. It's the shortest distance. So OC would be that perpendicular bisector, which would cut AB into two equal parts. All right, so let's take a look at this example. Point O is the center of the circle, and we have the line segment OC is bisecting the chord AB. Okay, so we're also told that angle OAC is 33 degrees. So OAC, that angle there is 33 degrees. We have to figure out X and we have to figure out Y. So X is pretty easy to figure out because it is an isosceles triangle, because this is a radius and this is a radius. You can see here they're equal in length. So that makes an isosceles triangle. So if this is 33 degrees, then this will also be 33 degrees. All right, and also we know that OC was a perpendicular bisector, so therefore we know this angle here is 90 degrees. So now that we know two of the three angles, 33 degrees, and we know this is 90 degrees, we can figure out this angle Y. All right, so just 180 degrees, subtract 90, subtract 33 degrees, and we get Y is equal to 57 degrees. Okay, so this next example, we have to use what we just learned about the chord property to find the length of segment BC. So B to C is here. And we can see it's a chord. And we can see what else we're given in this diagram is we do have this perpendicular bisector, which has gone through the center. So we know it is a perpendicular bisector. So therefore we know that these are 90-degree angles here. Both of them are 90-degree angles. What else we know is we know our radius from the center. Our center is called M in this question. This is our center to point A. That is a radius. So we know our radius is 15 centimeters. So let's just make a note of that our radius is 15 centimeters. And we need to figure out the length of B to C. So what we can do is work with this triangle. It is a right triangle. And if we can figure out half of the chord B to C, then we can, if we figured out this part here, then we can double that and figure out the length of B to C, right? Because B and C are equal in length. And how we're going to do that is we're going to create a smaller right triangle, knowing our radius. So from point M to point B, I'm going to draw another line here. That's another radius that I have drawn, right? It's going from the center to a point on the circle, and we know the radius is 15 centimeters. All right, so now we have 15 centimeters here from point M to the chord. We know that is 9 centimeters. So from here to here, we know it's 9 centimeters. So basically now we have drawn a smaller right triangle that looks like this. Okay, we know this is 15 centimeters, and we know this is 9 centimeters. So we can solve for that portion there. Once we have that portion from here to here, we can double it from here to here, and then we would have the answer for BC, line segment BC. And we're going to use the Pythagorean theorem. So we already have our hypotenuse, because this is the right angle here. This length is the hypotenuse. This length would be A. We need to solve for B. All right, so we know our formula, Pythagorean theorem. We know that A squared plus B squared is equal to C squared. We need to figure out B squared. So B squared is equal to C squared minus A squared. All right, so just fill that in. So 15 squared minus 9 squared, and I get 144. Oh, let me double check that. 15 squared minus 9 squared. Yes, 144. All right, that's for b squared. So remember to take the square root next to give b is equal to 12. And that is in centimeters. All right, so we've solved for a 12 centimeters is this portion here. So you would have to double that to get B. B to C. All right, so if this is point B and if this is point C, we would double that 12 centimeters to give us the length of B to C as 24 centimeters. All right, so in this example, point O is the center of the circle. A to B is a diameter with the length of 26 centimeters. C to D is a chord that is 10 centimeters from the center of the circle. So there's the center of the circle, there's the chord, it's 10 centimeters away. So what are we trying to find here is what is the length of the chord CD. So we have to figure out the length of C to D. All right, so just like we did before, we can use all the information given here, especially from the diameter. We know that our radius will be equal to 13 centimeters. All right, so you can create your little triangle, a little right triangle in this example. So for example, you could draw it from here to here, knowing that this line here is 13 centimeters long. All right, and we also know the second line is 10 centimeters. So basically, we have a small triangle now, like so. We know this is 13 centimeters, and we know this is 10 centimeters. All right, so using Pythagorean theorem, we can figure out E to D, and then double that to figure out C to D. All right, so that's exactly what they've done here using the Pythagorean theorem. This is the hypotenuse. So 13 squared minus 10 squared gives us the answer of 8.30. All right, but because that's only half the chord, we have to double it. So 2 times 8.307, which gives 16.6 centimeters long for the chord C to D. All right, so here we have a horizontal pipe. This is a pipe, like a cross-section of a pipe that has a circular cross-section. The center is labeled O. The radius is 20 centimeters. 20 centimeters is shown here as the radius. So water fills less than 1/2 of the pipe. So in blue, that's the water. The surface of the water, AB, so point A to B, is 24 centimeters wide. That's the chord, A to B is 24 centimeters wide. Determine the maximum depth of the water, which is depth C to D. So we need to figure out C to D. All right, so because we know it is a perpendicular bisector, we know that this will be equal to this. And we were told that AB is 24 centimeters wide, therefore A to C would be half that, so 24 divided by 2, that would be 12 centimeters. All right, so we can say that A to C here is 12 centimeters, CB is 12 centimeters. All right, so that's the diagram here. They've put here 12 centimeters. We have the radius as 20 centimeters. So we can use our Pythagorean theorem to solve for x, which is O to C. And then once we have OC, we know our radius, O to D, we know the radius is 20 centimeters, subtract x, and then we will have the measurement for that water depth. All right, so that is what they've done here. Again, this is the hypotenuse, and we're given B, so we're just solving A in the Pythagorean theorem. Okay, so 400 minus 144, this was 20 squared minus 12 squared, which gives us 256. Take the square root of that, we get x is equal to 16. So that means from here to here is 16. So take your radius, 20 centimeters, subtract 16 centimeters, and we get 4 centimeters for that depth of the water is 4 centimeters.